Welcome to Braille Institute. Now discussing the moment generating function. So it's called the MGF. So its name itself we understand that what is the moment and it is generating. So this moment is generating. So what is a moment? We can say about what's a moment. In physics we know that one fixed point, some body of mass is rotating some fixed point. So this the turning effects that we can call the moment in physics. But in statistics we don't have number of masses and all bodies are rotating around the one fixed point. So we have a lot of random variables. In statistics we have a random variables. For example, 1 3 5 7 9 8 6 4 2. We have number of random variables. So in these random variables, how to find out the central point, how to find out the central point? This is average. So we will get the average of 5, and some values will be here in this here in left hand side, and some values will be right hand side. So this value we can call this average value. So based on this average value, this all the random variables, these variables are based on this average value. Some left hand side, some movement in left hand side, some movement in right hand side, that we can draw in the curve, in the normal distribution curve. We know that so this is a mean, and some values we are drawing the left hand side, some values we are in the right hand side. So this mean is called the, so mean is a central point, the number of variables in nearby the central point. So this mean is called the first moment. First moment, we can call this a first moment. The first moment is a mean. So it's an average value. And second moment. Second moment. So what is second moment? The second moment is explaining the variance. Variance expectation of S minus mu whole square. So what is a variance? We know that it is a central point. Some spread is there nearby. This all the values is not in the not in the lying on the central point. Some spread will be there. It is a spreading here. So this graph is like that. So some values are spreading there. So this spread is explaining about the variance. So this variance is about the mean. It's about the mean. You can say that expression of S minus mu whole square. So that we can call the second moment. Third moment is a skewness. Skewness. What is skewness? Skewness is explaining the asymmetry. So this is a symmetry. There is no skewness. If you are drawing the asymmetry, that means this is one graph. You see this graph, there is asymmetry. It's not a symmetric. This left hand had said lot of values in left hand side. Otherwise one more graph, if like that. So this is a lot of values in right hand side. So this is symmetric graph, but this is a positive skewness, and this is a negative skewness, because a lot of values in right hand side. This is negative skewness, this is a positive skewness. So this is also as a standard moment. We can say that the expression of S minus mu all divided by sigma all raised to q. So skewness is explaining the symmetry. And next is the fourth moment. Fourth moment, we are here is studying fourth moment. Just we are studying only 4 moments. Fourth moment is kurtosis. You can call the kurtosis. So kurtosis, what is a kurtosis? Is explaining about the peakness and tail. What is a tail? So this is a graph. So this is a normal graph, and we have a sometime it will be explaining about the peakness, and sometime it will be explaining about the, there is no tail will be a more fat tail. So this is a fat tail, we can call this a fat tail. and this is high peak. So this is explaining about this character is explaining about the fourth moment, that is a kurtosis. That will be, you can call is an outlier. This fat tail means that is a outliers. More outliers will be there. That is why this is kurtosis. That is explained about the kurtosis. And so these four moments is explaining what is the shape of the distribution. These four moments is giving idea about what is the shape of the distribution. So how to find out these? So moment is generating. This moment is generating functions. That is a MGF. How to find out the moments? So we have a equation MST is equal to expectation of e raised to Ts. Expectation of e raised to Ts. We know that expectation of x. How to find out the expectation of x? Expectation of x is in a discrete case we can find out like that. Probability of x equal to x. And if it is a continuous case, we'll find out like that. F of x dx. So e raised to th. How to find out the exponential function e raised to th? So instead of x, we have to substitute e raised to ts. That's all. Here also you can substitute e raised to th. That's why both way we can find out the what is the MST. MST is representing moment generating function. T is the fixed variable. It is a vector, some constant vector, and x will be random variable. And expectation of e raised to ts. E raised to ts is equal to getting sigma e raised to ts probability. So this is a two way we can find out the moment generating function. And what is the use of this moment generating function? Moment generating function, only one use is finding out the what is a moment. And we in next class we will study what is the use of the moment generating function. There is some unique properties is there. And here we are finding out moment in about the origin. Here we are finding out about the origin. Finding out the moments in about the origin. So first moment will be about the origin is first moment is expectation of x. What is the second moment about the origin? Expectation of s square. About the origin means instead of mean we are putting 0. So about the origin will be expectation of s square. Here is third moment that we can call expectation of s cube. This also about the origin. So we can make a 0. So this is a third moment. And about kurtosis also will get about the origin s raised to 4. Like that we can find out expectation of h, expectation s square, expectation s cube, expectation of s square. That is the one purpose of the that why we are finding out the moment. Moment we are finding out about the origin only. So we can that we calculate in the next class. How to calculate the moment that we can calculate in next class. Here we are finding out the MST only. How to find out the moment generating function. So we have a two equation. One is the expectation of e raised to ts is equal to, it's a discrete case, e raised to ts probability of s equal to s, and it's a continuous case, e raised to ts is equal to f of s ds. For example, we can consider one discrete case. Probability of x is equal to x equal to 3 divided by 4 raised to x. X is equal to 1, 2, 3 up to the infinity. So we need to find out what is the moment generating function. So probability of s is equal to x is given 3 divided by 4 raised to x. X is equal to 1, 2, 3 to infinity. So moment generating function, we know that moment generating function MST is equal to expectation of e raised to ts. So this is 3 divided by 4 this is a function. So here it is we have to substitute here x is equal to 1 to infinity e raised to ts and probability of s by s 3 divided by 4 raised to x. So this is the formula. We need to expand. So this we can write like that. This we need to expand. How to expand here? Here just MST is equal to expand here. X is equal to 1. So x is equal to 1. We can write e raised to t 3 divided by 4 e raised to t, 3 divided by 4, 3 divided by 4 plus e raised to 2t, 3 divided by 4 square. Next 2 is given plus e raised to 3t, 3 divided by 4 cube. So it's going like that. So now you see this is on geometric progression. Geometric progression, sum is equal to, we know that sum is equal to a divided by 1 minus r. It's a geometric progression. First term is a we can write 3 by 4 e raised to t. And what will be the r? R value is equal to 4 is changing 1 by 4 e raised to t. So that is the value of r. There is a only change here, e raised to t and 1 by 4. 4 is changing here, one more t is added, e raised to t is added. So a divided by 1 minus r, we can substitute here, a divided by 3 divided by 4 e raised to t divided by 1 minus 1 by 4 e raised to t. So 4 we can write here. So 4 minus e raised to t divided by 4. This 4 we can cut. So this will get 3 e raised to t divided by 4 minus e raised to t. 3 e raised to t divided by 4 minus e raised to. So this is where we can find out what the MGF. So this is a discrete case. We have find out the MGF. Sum we find out, and this is a geometric progression. So S is equal to a divided by 1 minus r. And one more in discrete distribution, we know that it's a Poisson distribution. What is a Poisson distribution? Probability of S is equal to Poisson distribution. We know that the probability of S is equal to e raised to lambda raised to s factor, lambda raised to s e raised to minus lambda divided by s factorial. So this is the Poisson distribution. Poisson distribution under the discrete case. Poisson distribution is the discrete distribution. So expectation of e raised to ts, we can write expectation of s is equal to, this one will be s is equal to 0, 1, 2 up to infinity. So s is equal to 0 to infinity. This is a Poisson distribution. So e raised to ts, lambda raised to s, e raised to minus lambda divided by s factorial. So MGF we can write like that. MST is equal to expectation e raised to ts is equal to, we can write like that. So this is a Poisson distribution. So this is a Poisson distribution. Poisson. How to find out the MST? So there is a e raised to ts. This value is a constant, we can take out. So MST is equal to e raised to minus lambda is taken out. S is equal to 0 to infinity. Lambda and e raised to ts, we can write lambda e raised to t all raised to s divided by s factorial. So lambda and e raised to t taken together and all raised to h divided by s factorial. S is equal to 0 to infinity. So this one we can write e raised to minus lambda. S is equal to 0. If you give s is equal to 0, it will get 1 plus s is equal to 1, then lambda e raised to t divided by 1 plus h is equal to 2, lambda e raised to t square divided by 2 factorial, and s is equal to 3, lambda e raised to t is to 3 divided by 3 factorial. It is going like that. It is up to infinity is there. It is going like that. Here this term we know that expectation of x, what is the formula for the expectation of s? S plus s square divided by 2 factorial plus s cube divided by 3 factorial plus, it is going like that. That is e raised to h. E raised to h is equal to 1 plus s square divided by 2 factorial s cube divided by 3 factorial. If it is e raised to tx, then what will happen? Here is a t and t square, here is t cube, it will go like that. Here it is instead of th, here it is e raised to lambda e raised to t. So what will happen? 1 plus, instead of t we have to put lambda e raised to t, h. lambda e raised to ts. So here it is, instead of t we are putting lambda e raised to t. So what will be the value? Lambda e raised to t, lambda e raised to t square divided by 2 factorial. So this one we can write e raised to minus lambda, e raised to lambda e raised to t. This is instead of th, this is here it is a lambda e raised to t. So lambda e raised to t is the lambda e raised to t divided by 1 factorial, lambda e raised to t square. This is the same way. Here is comparing here 1 plus th plus t square s square divided by 2 factorial plus t cube divided by 3 factorial s cube plus it is going. So comparing here lambda e raised to t, that will be a e raised to, instead of e raised to ts, here it is a e raised to lambda e raised to t. So we will get the e raised to lambda e raised to t. So this one we can write e raised to lambda is common, lambda is taken out, e raised to t minus 1, e raised to lambda e raised to t minus 1. So this is a formula for the MGF. So MGF is equal to, for the Poisson distribution MGF we got that e raised to lambda e raised to t minus 1. This is how we find out the MGF of Poisson distribution. We just return the same formula and substitute h is equal to 0, h is equal to 1, h is equal to 2, h is equal to 3. We substituted and we compare with the e raised to ts. So e raised to ts we comparing here e raised to lambda e raised to t. So we got the Poisson distribution. Next, one more continuous distribution. We can take some example of continuous distribution. Continuous distribution, f of x is equal to, one example, f of x is equal to 1 divided by 2 1 minus x, 1 divided by 2 1 minus x. This x is minus 1 less than or equal to s less than or equal to 1. So s is following the interval minus 1 to 1. So our f of x is equal to 1 by 2 1 minus s. So how to find out e raised to ts f of x dx? So we can write here mst is equal to integration of minus 1 to 1 is a x is falling minus 1 to 1 interval. So e raised to ts, e raised to ts 1 by 2 1 minus x dx, 1 by 2 1 minus x dx. So we need to integrate here. Here we can write this one, we can write minus 1 to 1 e raised to ts, e raised to ts 1 by 2 is common, it taken out, and e raised to ts and minus integration of minus 1 to 1 e raised to minus x into e raised to tx dx. This is, we are separated integration. Integration is separated. Here it is 1 by 2 is there. This is the formula. 1 by 2 is common for both e raised to tx dx and minus 1 to 1 minus x e raised to ts. This minus we can, this is the same minus x into e raised to th. So this one how to integrate. So e raised to ts. So this is the first part, integration of first part, first integral. This is a second integral. So how to integrate this one? E raised to ts. This 1 by 2 is common for outside. First e raised to ts. E raised to ts. We know that e raised to ts divided by t. So this one is again minus 1 to 1. So this is one of the integral minus of s into e raised to ts. How to integrate x into e raised to ts? This is the first part. First part, and second, this we have to integrate is a first and second. There is a multiplication, so we have to integrate by parts. So x d e raised to ts, s into e raised to ts divided by t, and first parts into integration of second. So e raised to ts divided by t. This is 1. This is a minus 1 to 1, and minus of integral minus 1 to 1. Differentiation of first one. So 1 e raised to th divided by t. So this t is taken out here, 1 divided by t, and here we can give minus 1 to 1, and here we need to integrate again. So here if we are integrating again, minus 1 divided by t e raised to ts divided by t. So this t we can make a t square, and this also we have to put the minus 1 to 1. So we give the 1 and minus 1 to in x. Instead of x, if we give minus 1 and 1, then we will get mst. Mst is equal to, mst is getting mst is equal to minus 1 divided by t e raised to minus t plus 1 divided by 2 t square e raised to t minus 1 divided by 2 t square e raised to minus t. We getting the answer minus 1 divided by 2 t square e raised. So this is mst. If you give the 1 here and minus 1, then here also 1 and minus 1, here also minus 1 and 1, then substitute here, then we'll get the answer of minus 1 by t e raised to minus t plus 2 t square e raised to t minus 1 by 2 t square e raised to. So this is a method to find out the continuous case. You are finding out the continuous case, integration in the continuous case. As one more example we can do, the gamma distribution. Well known probability of x, we know that probability of is f of x. We can write f of x for the gamma distribution. Gamma distribution. So f of x, we know that f of x is equal to lambda raised to alpha divided by gamma alpha s raised to alpha minus 1 e raised to minus lambda e raised to minus lambda x ds lambda s. So this is the formula for the f of x. Lambda raised to alpha and gamma alpha s raised to alpha minus 1 and e raised to minus lambda s. Now we are substituting this equation. Now we are finding out the mst. How to find out the mst? Mst is equal to e raised to ts. We need to, again we have to write e raised to ts. So here it is 0 to infinity. H is falling 0, h and infinity. It is falling 0 to infinity. 0 to infinity e raised to th, and substituting this value alpha divided by gamma alpha and h raised to alpha minus 1 e raised to minus lambda h dx. Now we are integrating. E raised to ts is substituted here. So e raised to ts is substituted here. F of x is substituted here. And how to integrate this gamma distribution? So e raised to ts and lambda e raised to ts. So this one we can change. Here it is e raised to ts and lambda e raised to ts. So we can change it to lambda x plus th. So it will come like that. So instead of like that, we can write this one. We can write minus lambda minus th. We can write minus lambda minus th. So this is e raised to minus lambda x e raised to minus e raised to th, same. So dx we have like that. Now this term is gone. Now you see lambda raised to alpha, gamma alpha, s raised to alpha minus 1 e raised to minus lambda. Now this term, this is a e raised to minus lambda t. Here is e raised to minus lambda. So here this one we are putting gamma, alpha and lambda minus t distribution. Now we are comparing with the lambda and lambda minus t distribution, alpha and lambda minus t distribution. Alpha and lambda minus t distribution we are comparing here. So this lambda alpha is taking out 0 to infinity, lambda minus t raised to alpha divided by gamma alpha. So this distribution will be like that. S raised to alpha minus 1 e raised to minus lambda minus t s dx. Now you see this is lambda minus t alpha, this is a gamma alpha and lambda minus t. Here we substituted lambda minus t raised to alpha. So same effect we have to minus it here raised to alpha. Same, so it is cut. We can remove here. So same we have to substitute here. So this is the same equation. See, this same equation we added and divided we multiplied lambda minus t raised to alpha and divided lambda minus t alpha. So this term, this is a probability of 0 to infinity gamma alpha and lambda minus t distribution. So this probability will be 1. So MST is equal to lambda divided by lambda minus t alpha, this raised to alpha. So this is the MST. This lambda we can write here like that, lambda divided by lambda minus t all raised to alpha. This you can write, and lambda we can divide here. So what will you get? 1 divided by, here is lambda is dividing here. So here lambda divided by lambda minus t divided by lambda. So this one we can remove again. So 1 minus t divided by lambda all raised to alpha. So this 1 minus t raised to alpha, again we can change it to t divided by lambda raised to minus alpha. Alpha we can change to 1 minus t divided by lambda raised to minus alpha. This is the MST equation. This is the MST equation. 1 minus t divided by lambda raised to minus alpha. In exponential distribution, alpha is equal to 1. In exponential distribution, we will get alpha is equal to 1. So what will get? Alpha is equal to 1 means it is a 1 minus t divided by lambda raised to minus 1. This is a exponential distribution. Exponential. In gamma distribution, it will be 1 minus t divided by lambda raised to minus alpha. Exponential distribution, 1 minus t divided by lambda raised to minus 1. So this is the basic of the moment generative function. Next class we find out the gamma distribution, what is the MST for the gamma distribution, and exponential distribution, and Poisson distribution, and basic equation MST is equal to expectation of e raised to ts, that we can expand like that, e raised to ts probability of x equal to x, e raised to ts f of x dx. And next class we can calculate the moment. How to calculate moment? We studied, we can use this moment generative function for calculating the moment. Hope you understood about how to calculate the MST. Thank you.